Alright, so this lesson that we're going to talk about, this first lesson, and that I'm doing a video for you guys on, is on the zero and negative exponents. We've already been talking about the zero and negative exponents in class, so I just wanted to uh, talk briefly about what we did first in class. Um, so the first thing in class, what we did was I gave you an exploration. You had to basically look at the different exponents that we had. So we started out with 2 to the 5th, and that's the same as 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. So I get 4 times 4 times 2. 4 times 4 is 16. Times 2 is 32. So 2 to the 5th, 32. Then the next part in the table was 2 to the 4th, which is just going to be 1 less 2. So I just look at the 4 times 4, which is 16. 2 to the 3rd is just 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. And 2 to the 1st is 2. So you were supposed to write a conjecture based off the data that you got from the table. We also did 3 to the 5th on down to 3 to the 1st. And we did 4 to the 5th on down to 4 to the 1st. And so you were supposed to use this data to come up with a conjecture. And basically what we're doing here is every time we decrease in one power, decrease in my power, we divide by the base. So whatever the number is as my base, in this example it was 2 here, here it was 3, here it was 4. I would divide by that every time I decrease in power. Now this continues when I get to negative exponents. So that was the next part. I decrease from 2 to the 1st gives me 2. So going down to 2 to the 0, that's just divide by 2 again. 2 divided by 2 is 1. And we did the same thing with 3 to the 1st. That should be 3. And 4 to the 1st should be 4. Divide by 3 to get to 3 to the 0, which gives you 1. And 4 to the 0, which also gives you 1. So your conjecture you would be here, the first thing that they ask you is, what if I raise any number to the 0 power, what number do I get? You should see the pattern here is obvious. If I have any number n raised to the 0 power, that will always be 1. Now, n is not allowed to equal 0. So this is one thing that we're going to talk about soon. Then we continued into the negative exponents, so we go 2 to the negative 1. Let's just continue that pattern of dividing by 2 again. So 1 divided by 2 gives me 1 over 2. 3 to the negative 1 is going to be the same thing. I divide by 3, which gives me 1 over 3. 4 to the negative 1, you guessed it, it's going to be 1 over 4. Now if we continue this pattern, 2 to the negative 2, I just divide by 2 again. But dividing by 2 is the same thing as multiplying by 1 over 2. So 1/2 times 1/2 is going to be 1 over 4. Or I can think of it as this. I can think of it as 1 over 2 squared. So if I just compare 1 over 2 squared to 2 to the negative 2 power, all we really did was move that 2 to the 2 power down to the denominator, and now instead of a negative 2 exponent, it's a positive 2, but it's in the denominator. So if we have a negative exponent, that would be your next conjecture. If we have a negative exponent, it goes down to the denominator, so I have 1 over 3 squared now. One thing I like to say that helped me remember what I do when I have a negative exponent is I say, if I have a negative exponent, I have to cross the line. That line is my fraction bar. So if I cross the line, I have to change the sign of the exponent. Cross the line, change the sign. Cross the line, change the sign. Cross the line, change the sign. So if I have 4 to the negative 2, it's got to cross the line because I got to resolve that negative exponent. So when I cross the line, now it's 1 over 4, but it's got to change the sign. So 1 over 4 squared, which is going to be 1 over 16. And 1 over 3 squared is 1 over 9. So that's basically negative exponents. They go further into it to help you develop it further and see the pattern more clearly, but that's negative exponents. Then we talk about fractional exponents. So 2 to the 1/2. If you put this in your calculator, you'll see that 2 to the 1/2 you can't really do. This is actually going to be the square root of 2. Okay? If I did 3 to the 1/2, this would be the square root of 3. If I did 4 to the 1/2, this would be the square root of 4, which is 2. Okay? And this is one thing that they showed you. They took 4 to the 1/2, then I believe they did, not 8, it would have been 9 to the 1/2, then 16 to the 1/2, and so on. 9 to the 1/2 was 3, 16 to the 1/2 was 4. You should have noticed that if I square both sides, if I do 3 squared, that's the same as 9. Well, if I raise each side to the 1/2 power, I get 9 to the 1/2, and the 2 becomes a 1, which gives me the same thing. So this is the pattern you should have noticed. Every time you have a 1/2 power, you do the square root. The other thing that they talked about was, what if I have 4 to the 3/2? This ended up being, let's see, that's going to be 8. And the reason it's 8 is because I can rewrite this 4 to the 3/2 as 4 raised to the 1/2 cubed. Well, we know from before that 4 to the 1/2 is 2. So this is just 2 cubed, which we know is 8. So one thing you can think of this as is when I have 3/2 power, this is going to be the same as the square root of 4 raised to the 3rd power. Now, because of one of the properties of exponents that we're going to talk about soon, I can also rewrite this as 4 cubed raised to the 1/2. So this 4 cubed would then be 4 times 4 is 16. 16 times 4 is 64 to the 1/2, which is, again, the same as square root of 64, which you know is 8. So that's kind of what fractional exponents are. And we're going to talk a little bit more about the actual properties written out in the real form that they should. And so the conjecture you would have come up with these is that if you have a fractional exponent, it's the same as taking the square root of something. Now, our fractional exponent can change. It doesn't always have to be a square root. But I'll explain that once we get to the property for fractional exponents. Okay, so moving on to our next slide, let's talk about a little bit of information. So this is where I'm going to talk about the actual properties. These were the properties that you developed from questions 1 through 15 in the second page of the exploration that we did in class. So the first property that we explored was a to the m times a to the n. So what we're doing here is we're multiplying two numbers with different exponents, but they have the same base. So it's the same number raised to two different exponents that we're multiplying together. If you noticed, what in the exploration, what you should have been able to do is you should have been to expand out, like I think it was 3 to the 4th times 3 to the 5th. 3 to the 4th is the same as 3 times 3 times 3 times 3. And then I multiply that by 3 to the 5th, which is 3 times 3 times 3 times 3 times 3. Altogether, I have 3 to the 9th. All we did here from 3 to the 4th times 3 to the 5th gives me 3 to the 9th. Look at your exponents. What did I do to them? All I have to do is add them. So a to the m times a to the n is the same as a to the m plus n. And then the second property of exponents that we talked about was a to the m over a to the n. This is done very similarly to the multiply. It's the same property, only because I'm dividing instead of multiplying, I'm going to subtract the exponents. So this is a to the m minus n. And the next property that we talked about, which was one of the properties that we talked about, was the zero property. A to the 0 power is the same as 1. As long as a is not 0 itself. You can't have 0 to the 0 equal 1. That's not true. Okay? Because you can't divide by 0. Right? You can't divide 0 by itself. You can't divide by 0. It's not allowed. So this is not true. A cannot equal 0. Next part, a to the negative n. If you did the little problems, I think that would have been 1, 2, 3, 4, 5, 6, 7, and 8. Question 7 and 8. You would have found that the property is if a to the negative n, that's going to equal 1 over a to the n. And again, a to the n cannot equal 0, because if it does, then I have an unknown value, undefined. And really, it doesn't really matter what n is, as long as a is not equal to 0. So let's see. We have 4 properties so far. We got 5 more to go. So real quick, the next property that we talked about was the power raised to another power. So my first power is m, and I raise that to another power, n. You'll notice if I expand that out, it's like I don't remember exactly the numbers, but let's say it was 3 squared raised to the third. Well, the outer exponent is what I look at first. That tells me I have 3 squareds times itself. So 3 squared times 3 squared times 3 squared. And following the above property from before, which was up here, this is going to be the same as 3 to the 2 plus 2 plus 2, which is 3 to the 6th. Well, let's compare this with these. How do I get 6 from 2 and 3? We multiply. So that means my property is a to the m times n. Oh, that looks funky. And then the last property for this slide, and we'll move on to the next slide, is what happens if I have 2 things inside the parentheses multiplied together? Well, you'll notice that this I expand out. So if I had 3 times 2 raised to the third power, this is the same as 3 times 2, 3 times. Times 3 times 2 times, I'm going to put it here, 3 times 2. Sorry, you can't really see that underneath the logo. But 3 times 2 times 3 times 2, you'll notice I have 3 3s and 3 2s. So 3 to the third and 2 to the third, which I can rewrite generically as a to the n times b to the n. Then the next property is, what if before we did a times b to the n, which we said was a to the n times b to the n. So that's multiplication. And so what if I did division? If I have a over b raised to the n, what do you think it's going to be? You're right. It's going to be the same as the multiplication. I'm just doing a to the n power over b to the n power. Next property, last 2 properties. What if I have the fractional exponent, a to the 1 over n? This is saying whatever my n is, that's the root I take of it. That's the nth root. It's another way of saying the nth root. So this is the same as this here. If it was 1/2, it'd be the square root. If it was 1/3, so let's say I had 8 to the 1/3 power, this is saying the cube root of 8. And this is basically saying what number times itself 3 times gives me 8. In this case, it would be 2. And then the last property that we're going to talk about is a to the m over n. This is the same as, because I can use my powers of powers rule property, I can separate this out as, let's see, a to the m raised the 1 over n power. And we know from the last property I just wrote that 1 over n is the same as the nth root. So this is going to be the same as the nth root of a to the m. Now again, we can do this in a different order. So I can also rewrite this as a to the 1 over n raised to the m, which is the same as the nth root of a raised to the m power. And they should get you the same answer. If you didn't get the same answer, you did something wrong. It's just the first way looks a little cleaner. It looks nicer, so that's why we do that one. Alright, so let me just do a quick example for you, a few examples. Oop, let's get out of that little window there. There we go. Okay, so let's say I have, oop, I'm having trouble here. Hold on one moment, guys. Perfect, that's exactly what I wanted. Awesome. Thank you for waiting for me patiently. Our example problem is, let's say I have 2x to the 4th, y to the negative 4th, z to the negative 3rd, divided by 3x squared, y to the negative 3rd, z to the 4th. Now I can solve this many different ways, but the main thing is you have to remember your properties. So let's look at the 2 and the 3. They're two different numbers, so I can't really do anything with them, so they're just going to stay there. 2's on top, 3's on bottom. Next, I'm going to look at my x's. Since I have x to the 4th on top and x squared on the bottom, I'm going to do x to the 4 minus 2 on top. Remember, if I have the same base, I can subtract the exponents. And then the bottom, or the next one is y, so I have y to the negative 4 minus a negative 3 becomes a plus 3. And then for z, I have z minus 3 minus 4. Now you're thinking to yourself, well, why did everything go to the top? Remember, our property says if I'm dividing the same base, I can subtract the exponents. So let's just get rid of this line here so you don't get a little confused. So I have 2/3 times all of this, which is fine. So simplifying further, I still have 2/3. X to the 4 minus 2, 4 minus 2 is 2, times y to the negative 4 plus 3 is negative 1, and z to the negative 3 minus 4 is negative 7. So now we need to look at our next property, which is the negative exponent property. The 2 stays on top. X squared is a positive exponent, so it's going to stay on top as well. And then y to the negative 1, got a negative exponent, so it drops to the bottom with the 3. And z also has negative 7, so it also drops to the bottom with that negative 7. So I can erase the extra part of my line. So my answer is 2x squared over 3yz to the 7th. There's your example problem. And here is your multiple choice question. I will put this in the description of the video in case you can't read it if it's blurry or whatever. So just let me know, or you can just check that. So you might want to pause the video here to do the problem. And here's your free response question. Don't forget, fill out the form and make sure you describe what you're doing. Don't just give me your answer in the free response question. You need to describe what you're doing. All right? Good luck.